14.1, we start getting into trig identities and things of that nature. So you take a look, these are all your basic trig identities as we work through this stuff. Sine of theta is the same thing as 1 over the cosecant of theta, just like cosecant of theta was 1 over the sine. Secant of theta, we talked about 1 over the cosine, so therefore cosine has to be 1 over the secant. Tangents, 1 over the cotangent, so therefore cotangent has to be 1 over the tangent. So they're just reciprocal functions or reciprocal identities of each other. The tangent identity, this one's kind of important. Tangent of theta equals sine of theta divided by cosine theta. And the cotangent identity just kind of flips it. Cosine theta divided by sine theta. Problem 2 is about kind of verifying the trig identities. So what you're looking for is, can I turn something into something else? We know that secant of theta, if we go back, secant of theta is the same thing as the 1 over the cosine of theta. So going back to the problem, this is really sine of theta times 1 over the cosine of theta. Does that equal the tangent of theta? Okay, well, what's sine theta times cosine theta is really just sine of theta divided by cosine theta. Well, what is tangent theta? We'll go back again to this list. You know the tangent of theta is sine of theta over cosine theta. So again, how can I break this down and make it smaller? That's sine theta divided by cosine theta. So let's check. So this is actually equal to that. Now let's check out B, 1 over the cotangent of theta. Does that equal the tangent of theta? Now you could look at the trig identity here and say, well, tangent of theta equals 1 over cotangent of theta. Well, that's not what they're trying to do. They're trying to talk about how can you prove that it equals that. So again, what does cotangent of theta equal? Well, cotangent of theta really equals 1 over the tangent of theta. So when we divide by a fraction, remember, that's the same as multiplying by the reciprocal. So that's really 1 times the tangent of theta. And does that equal the tangent of theta? Well, 1 times the tangent of theta is tangent of theta. And yes, that equals, of course, the tangent of theta. Done. Now here's a few more key Pythagorean identities. Cosine squared theta plus sine squared theta equals 1. And so then working from that, you can deduce different things. Sine squared theta equals 1 minus the cosine squared theta. Also, cosine squared theta equals 1 minus the sine squared theta. There's a bunch you could do there, and so on and so forth. But again, 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. And they want you to verify that 1 plus tangent squared theta equals the secant squared of theta. So again, you're looking for, what can I do to turn this into something else? Now this one gets a little bit crazy, but bear with me. You get 1 plus, well, what's tangent squared theta? Well, tangent squared theta, tangent theta is sine over cosine. Sine theta over cosine theta. So tangent squared theta is sine squared theta over cosine squared theta. Does that equal the secant squared of theta? Okay, so let's work our way through the left side here. I have to combine those things. Well, to do this, I have to have common denominators. Well, my denominator is cosine squared theta. So I need cosine squared theta on the bottom of both things. Okay, does that equal sine squared theta? Or secant squared theta, I'm sorry. Okay, well, we know that this is this, sine squared theta, and it's fine. Well, cosine theta, what can give me 1? Well, remember, the same thing over the same thing is always equal to 1, so cosine squared theta over cosine squared theta is still 1. There's no difference there. So now you're adding fractions. You end up with cosine squared theta plus sine squared theta divided by the cosine squared theta. Remember, common denominators, just adding fractions. Does that equal secant squared theta? Well, if you look right above, cosine squared theta plus sine squared theta equals 1. So that gives me 1 over the cosine squared theta. Does that equal secant squared theta? Again, what do we know? We know that secant of theta equals 1 over the cosine, so obviously secant squared theta equals 1 over the cosine squared theta. So we're good there. Okay, bear with me because this one's going to get crazy as we work through this. So we got tangent squared theta minus sine squared theta. Does that equal tangent squared theta times sine squared theta? So how can I manipulate this to make it be what I want it to be? So let's work on the left side. Tangent squared theta minus sine squared theta. Tangent squared theta we always talk about is sine squared theta over cosine squared theta. It's kind of what we talked about last problem, minus the sine squared theta. Does that equal? I'm not going to write it every time. Okay, so let's keep working over here. To be able to subtract this, we need common denominators. So sine squared theta over cosine squared theta minus, well, we need cosine squared theta on the bottom here. So what I have to do is multiply sine squared theta by cosine squared theta because that will give me that on top. So sine squared theta times cosine squared theta. That gives me my common denominators of cosine squared theta equals that. So let's subtract them. That gives me sine squared theta minus sine squared theta cosine squared theta. And again, those are two things that you can't combine because they're different over the cosine squared theta. Does that equal tangent squared? Let me write it again so you remember. Times sine squared theta. Okay? Do those equal each other? So let's keep working on the left side here. Notice how we have sine squared theta here and sine squared theta here. Oh, I can factor that out, can I? Sine squared theta equals, I'm sorry, not equals. Sine squared theta, when I factor it out, times 1 minus cosine squared theta. Again, when I factor sine squared theta out, sine squared theta divided by sine squared theta is 1. Okay? Sine squared theta cosine squared theta divided by sine squared theta is cosine squared theta divided by cosine squared theta. Does that equal that? Okay? Well, what's 1 minus cosine squared theta? If we go back a page, 1 minus cosine squared theta is just going to be sine squared theta. Okay? Which is kind of weird, I get it, but it's what it kind of boils down to. So you get sine squared theta times sine squared theta over cosine squared theta. I'm running out of room, so I'm going to take it over here. I can pull the sine squared theta out of that top. So when I pull sine squared theta out, what am I left with? I'm left with just sine squared theta divided by cosine squared theta. And just like we've talked about all along, what's sine squared theta divided by cosine squared theta? That gives me sine squared theta times tangent squared theta. See how they match? Crazy, I know. Problem 5, simplify cosecant theta, tangent theta. So again, you're just trying to manipulate trig identities here. So again, what you're looking at is what's cosecant theta? You're trying to simplify it. Well, cosecant is 1 over sine theta. If you go back to that first slide. Tangent theta, what is that? Well, tangent theta is sine theta over cosine theta. Okay? Well, if we know anything about multiplication, we can cancel top and bottom. What do I end up with? I end up with 1 over cosine theta. Okay? So, what is 1 over cosine theta? Well, if we go back again to that first slide, 1 over cosine theta really just equals secant of theta. So the simplification of cosecant theta times tangent theta is secant theta. What you're doing here is you're really learning how to manipulate trig identities to further your understanding of trig functions.